This assessment asks us to predict which product would be best synthesized through a Michael addition reaction. For a Michael addition, that means we need the electrophile to be some kind of alpha-beta unsaturated carbonyl. And our nucleophile is going to be some kind of enolate, and so it will be an enolate derived from an ester. We'll form that enolate using sodium ethoxide in ethanol. And then we'll have an acid quench to finish the reaction. And so if these are the reaction conditions, which one of these products will be formed by this reaction condition? So let's number these carbons here. We've got carbons 1 and 2. Carbon 2 will be our enolate carbon. That'll be our nucleophile carbon. And it will attack carbon 3, the beta position of the alpha-beta unsaturated carbonyl. That makes this 4, 5, and 6. That means our carbonyls at the end of this process will end up at carbon 1 and carbon 5. And so that will be this third product in this list will be the product that's formed with a Michael addition. Having carbonyls at carbon 1 and carbon 5 is best synthesized through a Michael addition strategy.